by then they will have replaced the toner and the copy machine, and I can get it cleaned up. All right. We're gonna do a couple examples with the P-series test, and then we're gonna start our spring break.
10.4 was due on Tuesday when we get back. Is it still gonna be due on Tuesday when we get back?
I changed it, it's gonna be due on Thursday when we get back.
Perfect, thank you. Appreciate that.
And there's gonna be one more thing to talk about in 10.4 that we'll talk about on Monday when we get back. It's a remainder thing. The integral test only tells us if it converges or diverges, it doesn't tell us what it is. There's a way to estimate what it is, and there's a remainder theorem that we'll look at on Monday when we come back. All right, this is real simple. This is not gonna take a long time. If we have a sum as k goes from 1 to infinity of k to the negative 3 power. Well, that is equivalent to the sum as k goes from 1 to infinity of 1 over k to the third, right? So, first thing we consider is a divergence test. We look at that expression. As k goes to infinity, does this expression go to 0 or something else?
0.
To 0. Divergence test is inconclusive. It does not work. All right? So it's not geometric. It's not telescopic. We could use the integral test, but the p-test is easier. What does p equal here? What does the P-series test say about that? Look on your sheet so you understand. There you go. Converges. P equals 3, which is greater than 1. So it converges by the P-series test. Done. Could have we done the integral test? Yes. But would you want to when you can do this? No. So as we go through this, there will be many cases where more than one test can work, but one might be easier than the other. All right? K equals 1 to infinity. 1 over the 4th root of k to the 3rd. How do those index roots and exponents, how does that work? That's the same thing as k to what power? The 3/4, yes. This is the same thing as k equals 1 to infinity of 1 over k to the 3/4. The exponent is the numerator, the index is the denominator. Divergence test is going to be inconclusive because it'll go to 0. It's not geometric, it's not telescopic. We could use the integral test, but let's see if we can use the P-series test first. What would P be in this case? P equals 3/4. And is that greater than 1 or less than 1?
Less than 1.
Less than or equal to 1. What does the P-series test tell us?
It is a divergent.
Diverges by the P-series test. If we tried to do the integral, we would get infinity. One more. And we're going to start our spring break. The sum as k equals 4 to infinity of 1 over k minus 1 squared. Okay, this is kinda. If we put 4 in here, 4 minus 1 is 3. If we put, then go around, put 5 in here, 5 minus 1 is 4. Put in 6 in here, 6 minus 1 is 5. Correct? So could we then just write this as the sum as k, rather than starting at 4? Could we start it at 3 and write it as 1 over k squared? Would that be the same thing? Yeah? It would be, right? Yeah. If you put in 3 for k, we get this. Put in 4 for k, we get that. 5, and so on. Those are the same. All right? What's p? 2.
Oh, wait, 2,
The exponent.
Yeah.
Which is less than 1, so what's the p-series test say? I'm not less than 1, I'm sorry.
It's like-
Greater than 1. It's greater than 1, not less.
So it converges.
Converges. Now, let me show you another way to think about that. We could have put, if you want to get rid of this 1, you would make k plus 1, correct? Right? K plus 1 minus 1 would be just k. So if we put k plus 1 in place of k, now subtract this 1 from each side and you get k equals 3 to infinity. And simplify this inside here and you get just k squared, which is, so that's another way to think about it. Okay. That was kind of an intuitive look at the pattern way, here's the algebraic way.
I know the p series, it says k equals 1. It doesn't matter what value k is. Like if it's 4 or 5, it still could be applied for the p series.
K equals 1.
Yeah, that's what it says.
The p equals 1.
It also says k equals 1. You know, k.
Oh, you're correct. So the p-series applies no matter where the index here begins. If we begin it at 3, begin it at 4, begin at that, p-series still applies. Because it's concerned about what happens at the end when you're going to infinity. Okay? All right, again, there's one more thing. The last two problems in the assignment, I have not covered what you need for those yet. You can do everything else in 10-4. All right?